Okay, everybody, so today we're going to talk about coterminal angles, but before we talk about coterminal angles, let me take a quick second here to review a couple things with you. First of all, when we talk about the unit circle, we have some measurements as we go around counterclockwise, okay? 0 is right here. As we go counterclockwise, we have 90 degrees up here, 180 degrees over here, 270 degrees down here, and then as we get back to where we started, we have 360 degrees, which makes sense because when we throw the unit circle on there, we know every circle has 360 degrees in it. On the other hand, if we're talking about radians, okay, one complete time around the circle, that's 2 pi radians. So halfway around the circle would be 1 pi radians. If we go up here where 90 degrees is, that's basically taking 1 radian and cutting it in half or dividing it by 2. And then down here where 270 is, that's 1.5 radians, but we know that we don't show mixed numbers on the unit circle, so we're going to use the improper fraction 3/2. Now, on the sheet here, you'll see that we have a red angle. Now I know on your paper it's not red, but you can see on the screen here that it's red. This side down here is called the initial side, okay? Because this is where we always start. Since this is kind of our starting point, that's why it's called the initial side. That's where we start. We either go up or we go down. This other side, where we actually create this angle, let's call this, say, a 30-degree angle. The other side is called the terminal side. So this terminal side can be created by starting and going down, going in the negative direction, and then hitting that terminal side. That terminal side can be created by going on the positive direction and hitting that side. In any case, that's called the terminal side. So, what's the idea with this thing, coterminal angles? Well, let's actually look at slide 2, and then we'll come back and we will define coterminal angles. So here's that same 30-degree angle, with my red line there being my terminal side. Well, what if I started here, and instead this time I went this way and ended up there? Well, I know that when I go down, this is in the negative direction. When I go that way, that's my positive direction. So I have negative 90, negative 180, negative 270. I know this ends up being negative 330 degrees based on the fact that there's 30 degrees of an entire circle missing. Okay? If I kept going past that red line another 30, that would be a total of negative 360 degrees. Well, how did I really find that? Basically, I just did 30 minus 360. I subtracted 360 because I'm going in the negative direction, and that left me with negative 330. Okay? This would be called a coterminal angle because although it is a different angle, it shares the same terminal side as the 30-degree angle. So let's go back to our first slide here. And for a definition for coterminal angles, let's just write shares a terminal side with another angle. So a coterminal angle would be one that shares a terminal side with a different angle. In this case, we have a 30-degree angle and a negative 330-degree angle. Those would be considered coterminal angles. They share the same terminal side. So as we go back here, that was a coterminal angle going in the negative direction. What about the positive direction? Well, what if I start here and I go all the way around, so that's 360 degrees, and back to this same terminal side? Well, this would be a 390-degree angle. And I got that by doing 30 plus 360. Okay? So this would be considered a coterminal angle as well, just on the positive side. Now there are more coterminal angles out there. If I went around a whole nother time add another 360. Or if I went in the negative direction a whole another time, subtract another 360. Let's do another example. 55-degree angle. So if I start here and I go around this way, what's the degree measure? Well, if I just do 55 minus 360, that's going to leave me with a negative 305. So I know this is a negative 305-degree angle. Whereas if I start here and I go positive around once and back to that terminal side, well, that's going to be 55 plus 360, which is a 415-degree angle. So that thing's 415 degrees. All right. So on the next example here, I'm going to want you to go ahead and consider the fact that, okay, in the unit circle, we also have unit circle. Think about the fact that 2 pi is all the way around, pi is half the way, and so on and so forth. If I start here and go in the negative direction, now I'm not dealing with 360 degrees. To get that, I'm going to do pi over 3 minus 2 pi. Because remember, one time around the circle is 360 degrees, or it's also 2 pi. Now, how do I calculate this? Well, one of two ways. First of all, we treat pi as a variable and not as a number. Okay? So I'm actually going to throw a 1 in front, and I'm going to think of this as 1/3 minus 2. And whatever I get, I'm just going to tack a pi onto that. It's like having 1/3 of an apple minus 2 more apples. What am I left with? All right? And we can't have mixed numbers because on the unit circle we don't use mixed numbers. So to do 1/3 minus 2, well, one way we can do this is to find our common denominator. Okay, so if I want this to be over 3, I'm going to have to multiply both top and bottom by 3. Okay. Now in the calculator, you can do open parentheses 1 divided by 3 minus 2. It's going to give you a decimal. I don't want a decimal. So you're going to have to convert that decimal back to a fraction in your calculator. If it's a graphing calculator, that's math, enter, enter. Math, and then enter, and then enter again. But for the sake of just doing this longhand, 1/3 minus 6/3, that's a negative 5/3. So this angle, as I go all the way around, is a negative 5/3 pi. All right? Well, what if I'm going to start here and go all the way around and then back here? Well, this is going to be a positive coterminal angle. And now I'm going to want to do pi over 3 plus 2 pi. So basically I'm doing 1/3 plus 6/3, which is 7/3. So that would be a 7 pi over 3 angle. All right. So here's the idea, guys. Now that we've done that, we know that we don't necessarily even need a picture in order to find these coterminal angles. If I want a positive and a negative angle, well then I'm going to take what I have, negative 150, I'm going to subtract 360 once, and then I'm going to do the same thing, but I'm going to add 360, and as long as both of those that come out are one's positive and one's negative, then I've done my job. Well, in this case, negative 360, or negative 150 minus 360, that's a negative 510 degree angle. Whereas negative 150 plus 360, that gives me a positive 210 degree angle. So those are my coterminal angles, one positive, one negative. You'll see in the second one, though, where we have a bit of a problem in that when I subtract 360 from 494, I'm still left with a positive number. And that's not what I want. Okay, I don't want a positive number, I want a negative angle. So, you know, as you go to your calculator and you do 494 minus 360, you're going to end up with 134 degrees. Well, that's not negative yet, so I'm going to subtract 360 again. It's basically like saying, okay, I went around the circle once and I still don't have a positive angle. I'm going to go around the circle again. So negative 226, that's your coterminal angle. And then for the second one, I'm just going to do that 494. Actually, you know what? Yeah, well, let me just go ahead and add this. In actuality, 134 would be considered a coterminal angle because it shares the same side. This shares the same terminal side, and it is positive. So that one would suffice, or if you did 494 plus 360 and came up with 854, that one would work too. Either of those would work. The key is that when you're done, you say you're done, you think you're done, well, that one of those angles is positive, one is negative. So in this next one here, when I add 360, I'm left with, what is that? 360 minus 630, that's a negative 270. So there's a negative coterminal angle. And then when I add 360 again, that gets me to positive 90. So those are two different coterminal angles. They share the same terminal side. Okay. And then lastly here, what about when we're adding and subtracting using radians? Well, I'm going to add 2 pi to each of these, and I'm going to subtract 2 pi with the hopes that I end up with a positive and a negative. So keep in mind here, I do not want fractions, or I don't want mixed numbers, and I don't want decimals. I want this to be in the form of improper fractions, okay? So I'm really just looking at the negative 13/4 here. And 2 pi, when I have a denominator of 4, would be the same thing as 8 pi over 4. I'm just multiplying numerator and denominator by 8 pi over 4, or by 4. So in this case, when I do negative 13 plus 8, that leaves me with a negative 5 pi over 4. And the denominator, when I do negative 13 minus 8, I get negative 21 pi over 4. Now the problem is both of these are still negative. So up here I'm going to add 8 pi over 4 again. And that leaves me with a positive 3 pi over 4. So now I have a positive and a negative coterminal angle, or you could even use this one as a negative coterminal angle. What if it's 0? Well, 0 ought to be pretty easy. If I add 2 pi from 0, I just get 2 pi. If I subtract 2 pi, I'm left with negative 2 pi. Those are my coterminal angles. And then in my last one, I have 35 pi over 12. Well, what am I going to add or subtract here? Well, when you think about a denominator of 12, if I want to go from a denominator of 1 to a denominator of 12, I'm going to multiply the numerator and denominator by 12. When I do the numerator by 12, I'm sorry. Hold on a second here. Yeah, so think of it this way. So you have 2 pi, and you want this to become something over 12. Okay, we want a denominator of 12, so I'm going to multiply top and bottom by 12. So this is going to leave me with a 24 pi on the top. Okay, so here we're going to use 24 pi in my numerator. Okay, up here I'm going to get 59 pi over 12. And in the denominator, I'm going to be left with 11 pi over 12, which unfortunately is still not negative. So I'm going to have to go one step further, and I'm going to have to subtract 24 pi over 12 again. And that's going to leave me with a negative 13 pi over 12. Oops. So there's my negative, and you can use either this or this as your positive. Okay.